Hi, my name is Stephen Barella, and I will be doing a presentation for the JPATS Training Ops Parallel Facility, Naval Air Station in Milton, Florida. My scope of work includes the insulation for the project. So here we have a good view of the exterior of the building, which clearly shows that it will be a mason block wall structure. Now this signifies that we can't use the typical type insulation, the batting insulation that you put in between the studs. So the specs call out for a different type of insulation. Now this insulation will be a rigid board insulation. Now here's a good view in the plans of the interior walls. Now these interior walls will be classified as a partition wall. Now these will be able to utilize the batting insulation, which is the typical insulation you see found in most homes. And just to help visualize how this rigid board insulation works, because it's not as common as the batted insulation, I've provided this example. As you can see in the photo, the rigid board is applied directly to the face of the CMU wall. It is then finished with whatever the plans call out. And for this particular facility, the JPATS Naval Air Station, it calls out a brick finish, just like the photo. Now, going back to this Naval Air Station project and their specifications under Division 7 Thermal and Moisture Protection in the specific section 3.41 Installation on Masonry Walls, it states that the rigid board installation be directly applied to the masonry walls, which are the exterior walls, by adhesive or fasteners. Now the reason why they say or fasteners is just the nature of the installation. You won't always get a clean surface to put the adhesive for the board. Sometimes you'll have an extrusion by a pipe or any other type of mechanical systems, and that's why they fall back on the fasteners. However, in the section directly following 3.4.1, the next states that when applying the rigid boards to the exterior CMU walls by either adhesive fasteners or both, that the sides of the rigid boards should butt up against each other, following by being sealed with tape, such as the picture I've provided here. This just ensures that there is minimal air passing through the rigid boards in or out of the building. And as for those interior partition walls located towards the east side of the facility, those will be utilizing the batted insulation. Now, batted insulation, which can also be seen in these photos I've provided, is typically the pink insulation you see in most residential homes as well as commercial buildings, and the installation of it is fairly straightforward. So where the installation differs between the rigid board is that this stuff is a little easier to work with when making cuts or moving it around any sort of obstruction. And similar to most other applications of this batted insulation, this particular job states in its specifications that the insulation will be cut to fit the width of the adjacent wall studs in an orderly manner. It also states that the insulation shall be installed in parallel courses that go vertically along with the joints. Now this is important, and you can see that the worker in this photo is doing such that, even above the window, it's still being installed vertically. And here in the photo I've provided, you can see one of the sheets I used primarily to get a good idea and understanding of how the wall system works for the exterior of this building. You can see highlighted where I have the rigid insulation called out and just how it works with the rest of the wall system. So as you can see here, I've included the work breakdown structure diagram. Now, a work breakdown structure diagram kind of helps you visualize the work that's actually going to go into this scope, which is the insulation. So I was able to break it down into 3 different phases, which the first is being the CMU walls, the second the perimeter, and the third the interior walls. Now as for the work that follows these phases, they're all going to be pretty much similar. And just to help summarize the work that'll be going on for this job, I've included this work breakdown structure table. Now, the difference between the work breakdown structure diagram and table is that this table includes a little more detail and information about the work that'll be going on under each of the phases. For example, let's take phase 1, exterior CMU walls. There's 3 different levels of work, the first being the pre-installation inspection. Here is where we would go and ensure that all the areas that are to be insulated are free of any major issues that could cause a delay in completion. The second would be the actual installation of the board. And then the third would be a final inspection by a city official to ensure that all the areas that were insulated were done correctly. For this particular scope of work, the work that needs to be completed prior to the insulation being installed is pretty obvious. The exterior walls need to be completed and approved before the rigid board can be installed, as well as the partition walls interior of the facility need to be approved and completed prior to the insulation being installed. Now, that also includes all of the plumbing, mechanical, electrical, anything else that's going to be ran through that walls also needs to be completed prior to the beginning of the insulation being installed. Even though this scope of work isn't as complicated as, for example, the roof trusses or the concrete pad, special considerations are still to be made. For example, safety is always number one. Another good example would be a lead time to get the material in from our supplier. So here we have the sheet that I used to mark up to get the estimate for my exterior walls. Now again, my exterior walls used the rigid board insulation with an R19 value. I got a quantity of 4,137.75 square feet for the total area for the rigid board. And similar to the last, I used this particular sheet to get the total area of interior partition walls, which would be utilizing the batted insulation with an R19 value. So I got a total of 3,072 square feet. So before I was able to reach a total cost for all insulation that would be installed into this facility, I had to first break down both the rigid and batted insulation because each one had their different quantities as well as different daily output, labor hours, materials, labor, and including overhead and profit. So after getting subtotals for both the rigid insulation as well as the batted insulation, I was able to include the overhead and profit to get a total cost for all of the insulation that will be installed in the facility at a number of $14,976.20. And lastly, one of the most important parts of this scope, which would be the duration. So here I have shown a table that shows the task, the materials required, tools and equipment, and the crew size, and then of course followed by the estimated duration. So for documentation, I estimated 15 days. Material purchases, I estimated 12. Exterior wall insulation, I estimated 3 days with a crew size of 1 carpenter, as well as the interior partition wall insulations, I estimated a 2 crew carpenter size with an estimated 4 days. And lastly, I have a few risks and a couple of exclusions I think are worth noting. One of the exclusions would be we would not be installing any of the insulation for the plumbing, mechanical, HVAC, or electrical systems. The respective contractors should be responsible for this type of work. Also, all of the walls should be completed prior to the beginning of the installation. And a few risks I think are worth noting as well that would be a major impact to the scope would be delay of material, a delay of initial start date, and also equipment failure or site access. I hope that the information that I've provided you today in this video has helped you understand my scope of work, which was the installation for this JPATS Training Ops Paraloft facility in Milton, Florida. Once again, my name is Stephen Barella, and thank you for watching.